I request all of you to check this one. Just now I have started. The recording was stopped automatically. I did not do anything. So, so quickly we will start the class. And so before starting the class, I just want to know whether what is the flexible time for all of you. 6 to 7:30 or what you want some other time. I will be available from 4:30. Okay. So what is the flexible time you tell me? So I want all of you to join me. Why? Because instead of listening to the recordings, the live section will be very useful for you, and it will be interactive, and then and there itself you can clarify your doubts. Okay. So it's up to you. Just all of you just drop a message like which time is better for you. 6 to 7:30 or to 8, Ganesh. And how about others? If 6 to 8:30, 6 to 8 is better. Sometimes from 6 to 7:30 or sometimes from 6:30 to 8, like that I will take. So if you have any inconvenience in the timings, just please let me know. Okay, now so let me quickly in 5 minutes I will tell you what are the things that we have revised. Okay. What are the things that we have revised? Okay, we were discussing about the base of VLSI. Okay, introduction I have told you like VLSI is existing and it is most popular just because of MOS technology. Okay, so what is the beauty of the MOS technology means less power consumption. Okay, less power consumption. They will operate with very low power. And the second thing is scalability. Okay, scalability. Scalability means yesterday I have explained you about Moore's law. Like today, if you are able to accommodate 10 transistor on a chip, in after 2 years, the transistor count will be doubled. The chip size will be same. Okay, chip size will be same, and the transistor count will be doubled. It happens for every 2 years. Okay, that is what is called as Moore's law. Okay, the beauty of MOS is scalability. We can reduce the size. We can reduce the size. Okay, the size of the MOSFET is defined by, so we can scale up. Scalability means reducing the size. The size of the MOSFET is decided. What size of the MOSFET is defined by the length of the channel. Okay, length of the channel. Okay, channel length is nothing but distance between source to drain is nothing but the channel length. Okay, all these things we have discussed yesterday. Okay, and next in MOS, what are the two different types of MOS comes in two flavors. One is PMOS and then NMOS. Okay, so one is in PMOS we have depletion and enhancement. Okay, and in NMOS we have in MOS also we have depletion and enhancement mode MOSFET. Okay, we have seen the operation of NMOS enhancement mode transistor. So MOSFET it will operate in three regions. It operates in three regions: cutoff, okay, cutoff, active, and saturation region. These are the three regions of operation of MOSFET, and the conditions also we have seen in the very first class. You can go to the video. Next one is we know the advantages and drawbacks of PMOS and NMOS. NMOS, the speed is more and consumption, power consumption is also more. Why? Because To turn on the NMOS, always we require maximum voltage. Okay. So NMOS will operate with only logic 1. Okay. So if to turn on PMOS, if PMOS will operate with zero input voltage, PMOS will turn on with zero input voltage, NMOS will turn on with, so this is PMOS and this is NMOS. Okay. So PMOS will turn on with zero input voltage, NMOS will turn on with input voltage 1. Advantage of PMOS is very with low, almost with zero input, the transistor is getting on. In NMOS, always it requires high. Okay, power supply consumption will be more. Okay, next one, in PMOS it is very slow. Why? Because the majority charge carriers are electrons. NMOS it is very fast. Why? Because the majority charge carriers are holes. The mobility of electrons is greater than the mobility of holes. These are faster, these are slower. Okay, so they requires more power, they requires very less power. They requires very less power. So to avoid the drawbacks of NMOS and to avoid the drawbacks of PMOS, we are combining PMOS and NMOS. Okay, PMOS and NMOS, which is nothing but CMOS. Okay, so these are the things we have discussed yesterday, and we have seen ASIC design flow also. We have seen ASIC design flow also. So in ASIC design flow, quickly I will show you the PPT once again. In ASIC design flow, we will start with system specification. First thing is to design anything, we need the specifications. So after system specification, we will design the architecture. Specifications and yesterday I told you, like the technology you have to decide. Okay, so the input power consumption, and what is the supply voltage? What is the supply voltage? It has to operate, and what is the speed of operation, frequency, and also how many inputs, how many outputs. Like example, if you are designing a processor, whether it should be a 16-bit processor or whether it is a 32-bit processor, these are all comes under clock frequency. Okay, all these things comes under specifications. Then you will design the architecture. So architecture, with architecture, you can either go for a Verilog or VHDL. See, after the architecture we will break into modules. Okay, we will break into modules. Let us suppose if we, example I have told you. So if we are designing an ALU, in ALU we'll be having arithmetic units and logical units. So these arithmetic units and logical units are treated as the submodules. These submodules are designed. Okay, the submodules are designed separately and again they are combined. Okay, after designing the submodules, you will be designing the circuit. Okay, after designing the circuit means nothing but schematic. Okay, schematic. After designing your schematic, then you will go with physical design. In physical design, again there are many steps, like you have to go with partitioning, floor planning, placement, clock tree synthesis, signal routing, and timing closure. See, all of you, do you know about all these things? You know functional design, you know logic design. Logic design means with the help of what you will be seeing in your logic, you will be seeing all the gates only. Okay, so with these gates, you will be designing your architecture, complete architecture. It will be broken into modules. Each and every module is nothing but each and every module is implementing one function. So that function related logic, you will automatically, the CAD tool will generate. And after that, for your logic, you have to design your circuit. The circuit design also automatically the system will generate the circuit. Okay, after the circuit design, you will start the physical designing. Physical designing means it will be also done in the CAD with the help of CAD tool only in the system, physical design also. So In physical design, you will go with partitioning, floor planning, placement, clock tree synthesis, signal routing, and timing. Screen is not visible. I have shared this one image. Are you able to see that? Are you able to see this image? Yes, you are able to see, right? Somewhat. After zooming it up, something there is a blur. So, right. So, now just tell me. So, do you know about partitioning, floor planning, placement, clock tree synthesis, signal routing, time enclosure? Do you know all these things? Ivanni తెలుసా తెలీదా చెప్పండి. Okay, I will explain. Okay, you remember partitioning, planning, placement. So, can you see the Word document now? Word document. In this Word document. So, first thing is partitioning. Partitioning. What next? Floor planning. Floor planning. Third one is placement. Fourth one is routing. Placement, clock tree synthesis, signal routing. Actually, all these things are also part of ASIC design flow. Clock tree synthesis, signal routing, and time enclosure. All these things comes under physical design. Okay. All these things comes under physical design. Yes, physical design related. So, right. So see here. Normally, when we take the we will write the RTL code. The best example is I will always take the example of ALU only. Okay, so you have the RTL code for ALU. After writing the RTL code, next what happens is you will do after your simulation. In between simulation comes. Okay, after your simulation and synthesis, what happens is your RTL code will be converted into what gates. Okay, so you will get a logic diagram. Okay, you will get a logic diagram for your ALU. So actually, this logic diagram you can if you are taking an ALU as a big module, what happens is you will be having the blocks. Okay, you will be having the blocks. Let us suppose this block is adder. Okay, this block is multiplier. Okay, this block is encoder. Okay, this block is something X block, Y block, Z block. You all know what will be there in ALU. I need not tell you. Logical gates also will be there, right? Logical blocks. So these are the different blocks in the ALU. Okay. So these are the submodules. Okay. ALU is the biggest big module. Okay, main module, and these are the submodules. So whatever the submodules are there, okay, whatever the submodules are there. So what you need to do is you need to place, let us suppose your ALU is having 10 submodules. Okay, 10 submodules are there in your ALU. Okay. Let us suppose it is having 10 submodules are there. 10 submodules are there. But see here, when what vendor is giving you the specifications, okay, so the size also will be mentioned, like I will give you a floor, I will give you an area in the IC of 2 mm into 2 mm. Okay, this is your required floor. Example is, if you want to construct your house, okay, you will be having say this 200 square yards of area. You have to plan everything: kitchen, water, bathrooms or bedrooms or hall, whatever it may be. Everything you should plan in that 200 square yards only, right? Okay. Here the same thing. Floor planning is also the same thing. So see here, before floor planning, partitioning we have to do. So in this, whatever these are the different modules. In these modules, digital modules will be there. Okay, analog modules will be there, and also there are mixed modules. Okay, mixed modules also will be there. Okay, so all these modules you need to separate. Okay, all these modules you need to separate. That means you are partitioning the modules. You are partitioning the modules. After partitioning, what you have to do is you have to do the floor planning. So given floor is 2 mm into 2 mm, in this 2 mm by 2 mm only, you should to fix up all the modules. Okay, you should fix up all the analog and digital modules. Okay, so see, you should not exceed this boundaries. You should not cross the boundaries of 2 mm by 2 mm. Okay, you have to plan in the given area. That is what is called as floor planning. So let us suppose if something is happening, so if you are crossing the boundary, then you cannot go proceed further. See, this floor planning also happens in system only. In the system only you will be doing. So you CAD tool, it will check whether you are crossing the boundaries which are given to you. Okay. So if you are see if there is anything wrong here, if you are not able to fix up the modules in the given area, again you have to go back and start the procedure once again. Okay. And you have to go back to your simulation or synthesis. Again, you have to develop the mod, or else. So whenever you are doing your RTL design only, you have to mention the specifications, like how much transistor size I have to take, whether I have to fix in this floor, what is the transistor size. You have to think all these things and then you have to start the design. Otherwise, if you are not concentrating on the transistor size, definitely, and you are coming to this step, again you have to go back. Okay, so this is what is called as floor planning. Floor planning, floor planning and placement both are similar only. In floor planning, you will decide. So in floor planning, you will decide the space for what? So and so analog modules, this is the space. I will place the digital modules here. I will place the logic gates here. I will place the multiplier here. Like that, first thing is you have to plan. Okay. So first thing you have to plan, and the second thing is you have to place. Okay. Now you have to place. That is what is called as placement. Next one is clock tree synthesis. Okay. Clock tree synthesis means this is very important concept. Okay. So might be after joining a job, you will be completely will be working on clock tree synthesis, clock domain crossing, and all those things only. This is one area. This is one particular area where the what engineers will be concentrating only on this clock tree synthesis. Okay. So See here, clock tree synthesis means you have placed all your modules. Okay. After placing all the modules, so what you have to do is you have to give the clock. Okay, you have to give the clock. Clock should go for all the modules. Okay, clock should go for all the modules. So each and every module requires power. Each and every module requires power. Okay, so see, clock should, whatever the clock signal is there, clock signal should reach all the modules 1, 2, 3, 4, 5, 6, 7, 8, 9. And here in clock tree synthesis, one more important thing is, so clock signal is reaching module 1 at what, module 1 in one particular time. It is taking, let us suppose, 2 nanoseconds. So the clock signal is reaching module 2 in 4 nanoseconds. Why? Because the distance is more, the wire length is more. Okay, so the time, there will be time delay. If you take module 3, the clock signal is reaching at 6 nanoseconds. If you take module 4, 2 nanoseconds. Okay, so here 4 nanoseconds, and here it is taking 6 nanoseconds. So clock signal is reaching different modules at different timings, different modules at different timings. So if the clock signal is reaching different modules at different timings, is it a drawback or is it an advantage? Can anyone tell me? It is a drawback. Why it is a drawback? Why it is a drawback?
మనం ఒక బ్లాక్ ఆన్ అయినప్పుడు ఇంకో బ్లాక్ ఆన్ అవ్వడానికి కొంచెం టైం పడుతుంది మేడం.
Yeah. See, simple thing is we cannot determine the system performance. See, all the modules should work at the same time. If all the modules are, see, all these modules are interconnected with each other. Okay, 5, 6, 6, 9. All these modules are interconnected with each other. So if any, when I give the clock signal, it should reach all the modules at the same time. Then only my circuit will work perfectly. Perfectly. If two modules are getting, see, each different module is getting the clock signal at different time, the performance cannot be determined actually. Okay, the performance cannot be determined. Okay, that is a drawback. So all the see, the clock signal should reach, signal should reach to all the modules at the same time. So మరి ఇప్పుడు ఏం చేస్తారు చెప్పండి? If the clock signals has to reach all the modules at the same time, what is the solution? Can anyone have the idea? Solution ఏంటి మరి? అన్నిటికీ ఒకటేసారి క్లాక్ వెళ్ళాలి అంటే, ఈ మొబైల్ ఫోన్ కూడా ఏంటిదనంటే, మనము బ్యాటరీ, మన ఫోన్ ఆన్ చేసినప్పుడు ఏంటిదంటే, బ్యాటరీ త్రూ పవర్ ఇట్ విల్ గో టు ఆల్ ది మాడ్యూల్స్ అట్ ద సేమ్ టైం. That's why we are able to operate camera, operate చేయొచ్చు. తర్వాత దాంట్లో speakers, all the modules are working at the same time parallelly. Why? Because the clock signal is reaching all the modules at the same time. See, how can I make the clock signal to reach all the modules at the same time? అన్ని మాడ్యూల్స్ కి ఒకటేసారి క్లాక్ వెళ్ళాలి అని అంటే వాట్ ఐ హ్యావ్ టు డూ? వెరీ గుడ్. We should give delay to some modules. Okay, we should give delay to how can we give the delay? How can we give the delay? Using timing scales. Yes, using timing scales. సో టైమింగ్ స్కేల్స్ ఎలా ఇస్తారు చెప్పాను కదా, మాడ్యూల్ ఉంది. ఓకే, దీస్ ఆర్ ద డిఫరెంట్ బ్లాక్స్. ఓకే, సో నేను 6 బ్లాక్స్ చూపిస్తాను. క్లాక్ సిగ్నల్ ఇవ్వాలి. క్లాక్ సిగ్నల్ what ikkada clock signal is reaching quickly to this one first module and fourth module. And here it is reaching late. The signal clock signal is reaching late. So late, and here also late. The arrival time is late. So what we have to do is we need to add the buffers. Okay. So chudandi, the maximum time is 3 and module 6 and module 3 are taking the maximum time. Okay. So for the modules which are taking the maximum time, we need not add any buffer. Okay. We need not add any buffer. ఇక్కడ ఏంటిదనంటే we will add the delay buffers. Okay. So ఇక్కడ 2 delay buffers I will be adding 2 delay buffers. Okay, 2 delay buffers. And for this module 1 also I will be adding, it depends, delay 3 delay buffers నేను add చేశాను. So these delay buffers, whatever I am adding, they will insert the delay. Okay. So ఒక వైర్ కి నేను ఇట్లా delay buffer నేను యాడ్ చేసినప్పుడు these buffers, they will insert the delay. Okay, they will insert the delay. Okay, so like that I can add the delay buffers, and I can make the clock signal to reach all the modules at the same time by adding the delay buffers. So ఇది one solution. కానీ ఇంకొకటి ఏంటి అని అంటే there are ఇప్పుడు if you go into deeper ఇంకొక కాన్సెప్ట్ ఏంటంటే, సో H-tree అనాలిసిస్ అని ఉంటుంది. ఓకే, H-tree క్లాక్ ట్రీ సింథసిస్ లోనే H-tree అనాలిసిస్ అని ఉంటుంది. ఆ క్లాక్ ట్రీనే సో ఈ హెచ్ షేప్ లో మాడ్యూల్స్ పెట్టి, సో ఇన్ బిట్వీన్ యు ఆర్ పుట్టింగ్ ద క్లాక్ సిగ్నల్ అండ్ యు ఆర్ మేకింగ్ ద క్లాక్ సిగ్నల్ టు రీచ్ ఆల్ ద మాడ్యూల్స్ ఎట్ ద సేమ్ టైమ్. H-tree analysis is there, T-tree analysis there. So there are many types of analysis, which is not our role actually. So I am just giving you the information, that's it. Normally interview related also, you can say that you need to add the delay buffers. So these delay buffers, yes, hybrid tree connection. So these delay buffers, they will insert the delay in the wires. Okay, so this is this clock tree synthesis we have seen. Okay, clock tree synthesis tarvata next step em chestam cheppandi, signal routing. Signal routing అని అంటే, సో క్లాక్ అనేది రీచ్ అయింది, క్లాక్ ట్రీ we are okay with clock tree synthesis. Again signal routing అంటే, see, for this module, for this chip, it needs supply voltage and it needs VDD and VSS. VDD and VSS are must and should. So this VDD also, see, if one module is getting the supply voltage, then output nundi module, then output nundi module, and from the output of this module, so like that we can give the supply, or directly VDD should reach all the modules at the same time. Did you understand my question? So ఒక మాడ్యూల్ కి మనం సప్లై ఇచ్చినప్పుడు with the output of this module we can drive module 2. With the output of module 1, the module 2 can be driven. So like this we will give the supply, so that the VDD should reach all the blocks at the same time. Yes, VDD should, all the blocks should get the supply at the same time. Okay, all the blocks should get the supply at the same time, and all the blocks should be connected to VSS. Okay, VSS at the same time. Okay, so this is what is called as signal routing. All the what blocks should reach the all the blocks should, the signal should reach all the blocks at the same time. After signal routing, after clock tree synthesis, and after signal routing, you have applied VSS to all the modules. Sorry, VDD to all the modules. You have given VSS to all the modules. You have given clock also to all the modules. Okay, so you have given clock to all the modules. So after doing all these things, next thing is we will check for the timing. Okay, you will do the timing analysis. Even why? Because clock signal or what it's VDD. So we will be using the metal wires. Okay, we will be using the metal wires, and we are giving the interconnects. Okay, ఇప్పుడు బ్లాక్ టు బ్లాక్ మీరు కనెక్ట్ చేయాలి అనన్నా, and at the same time if you want to connect all the blocks to the supply VDD, or if you want to connect all the blocks to the supply VSS, or if you want to connect all the blocks to the clock, so you have to use the metal wires for interconnections. Okay, metal wires for interconnections. Normally, when you are using the metal wire, okay, metal wire. So metal will be having some parasitic resistance, and it is having some parasitic capacitance. Okay, wire will be having some parasitic resistance and parasitic capacitance. Okay, so this parasitic, what do you, okay, all of you know about parasitic? What is the meaning of parasitic or parasitic? What you call? Do you know the meaning of parasitic or parasitic? For interconnection of the blocks, I'm using the metal wire for the interconnection of the blocks. Okay, to connect to supply also, I'm to connect to the supply voltage and to connect to the clock also, I'm using the metal wires only. Whatever these lines you are seeing, these are all the metal wires. So if I take a wire, okay, so a wire will be consisting of parasitic R, parasitic C, parasitic resistance. These are parasitics means unwanted. Parasitics are unwanted R and C's. So R and C together, if you are combining, it is nothing but T. So T is nothing but unwanted time delay. Okay. So that's why even though we have done perfect clock and signal routing, even though it is very much perfect, but still we cannot this module will not generate the output on proper time. Why? Because as the interconnected wires, they are having parasitic values, it will cause the delay. So as an engineer, our duty is to concentrate on this RNC, and what we have to set or adjust all the things. We need to reduce this parasitics. Okay, the parasitics reduced. You need to reduce this parasitics. Okay, so 1 second, my laptop is having less charging. What I will do is I will uh, stop here. I will stop here. One more thing is you will check all the parasitics, and you will sign off. That is timing closure. I will stop here and I will ping you back. Why? Because there is a power cut in our home actually. I will just I will text you when power comes. Okay. So just put one okay. I will definitely start the class, but that getting down. Okay, thank you. Battery I paint the